In today's episode, um, we're basically talking about how to make a full Linux OS using a Docker container. Now, this is a bit counterintuitive because we are all used to running Docker, but Docker usually runs on top of Linux and it uses the kernel um, and all the kernel modules, etc., from your OS. And so when we say we're going to take Docker and we're going to build the whole OS out of it, it does not make sense. So um, let's look at what this concept is. And before I go into this concept, I wanted to basically quickly mention where I got this idea from. I did not come up with this idea myself, but it seems like others have played with these ideas. And one such person is Ivan um, Volishko, and I ran into his blog. And on his blog, basically, he talked about the fact that he explored um, the Docker container. He found that it was uh, root file system files, and then from there he figured out that if he could add the kernel in it ramfs and a few other things like modules, kernel modules, and so on, then it made a full OS, right? So he had figured this out, and by adding those kernel modules and Linux image and kernel modules, he basically was able to build a full blown OS, and then he converted that into an image, and so on and so forth. So the idea then from there, the inspiration for this video comes from Ivan, and basically what I did was I saw the same thing, that the file system inside the Docker container, if you do an ls on it, it's basically um, composed mostly of the files. Now, your container may be really small, it doesn't have to have the full file system, but if you start with something like a Ubuntu image or a Alpine image or something, it'll look like, if you do an ls inside your file system, or if you try to look it under a dive, and I'll show you that tool later, you will see that it looks like a full file system, but it's missing the components that connect it to the kernel, like the headers, kernel headers, modules, the pluggable, loadable modules. The kernel itself is missing and initrd is missing. So the idea for building a full-blown Linux is that given a Docker container, Linux does allow you, like if you're in Ubuntu, you can always, um, add a module. Linux allows you to add modules, and it allows you to apt install using your package manager. Allows you to install all these components. So the idea then is from there is to get inside our Docker container, add all these. Now, if you run Docker itself, the image, the container, it's still okay because the way Docker hooks into the container is not through the traditional method by which Linux boots. So Docker still uses the kernel from the main operating system, and it'll go call the executable that needs to be called, the application. And so Docker can still work with that image. But now, if you just think about this image slightly differently, if we think that we are coming from the bootloader, and from the bootloader, if we just plug into the kernel, right? So that's I think the idea that Ivan had was that if you're coming from this bootloader instead of the Docker container, the bootloader is going to call this kernel. The kernel is going to call the initramfs, and the initramfs will eventually call the root file system. So the path inside that image is slightly different when you load it on top of the host rather than when you're loading this image inside a Docker container. So that is what we are going to do here. Now, the other thing is that while we are adding these things, a couple of very interesting things, very important things to add are things like Network Manager, which can even, I have successfully loaded Wi-Fi onto this image itself. Um, and remember that I'm not loading, like, to not make it very heavy. I'm not loading things like the the GUI and the window managers and so on, right? Um, I'm not adding any of that. I'm just leaving its command line so that we can add only the packages that we really need to keep the image size small and the memory footprint small. Um, but we will add the network manager, and we also want to add OpenSSH server so that when this machine is running, it could be running as a headless machine. We can just SSH into it, see the status of things, or launch applications and so on. So the first part of this is to understand what the idea behind building a Linux image from Docker is, and that's this idea. And next is how once we have built this image, so let's say you ran Docker, you did the inside the Docker, you did the apt install all the packages like Linux, the modules, and so on and so forth. And then how do we install it? So for installation, what we have to do is that we have to take a, let's say we are doing it on a USB. It could be a hard disk or a USB, doesn't matter. I was trying on a USB because then I don't disturb the partitions in the main hard disk that already may have like Windows OS or something else. It doesn't matter because I'm going to boot from a USB stick. I just have to make sure the USB stick is its own bootable OS. And so for that, what I did was that I partitioned my USB stick into two partitions. The first is the FAT32 partition, which is where I'll load the grub, and I'll also install the kernel and also the initramfs. Remember, the sequence is that the bootloader will call kernel, kernel will call initramfs, initramfs will then call the root file system and will be up and running. So this is exactly why I partitioned my USB into two parts. And you can use gparted or parted, whatever your favorite tool is, but just start with um, a very simple partition table in the DOS mode, and then add a 2 GB FAT32 partition, and then adds whatever remaining, whatever you want to. Probably I would say maybe at least 4 or 5 GB of space for the root fs, and it should typically be bigger. I have like 30 gigs on my root file system. So, and the root file system, if we go to the next one, the root file system could be ext3, ext4, whatever you prefer it to be. Just format it, format your USB drive in that partition, and then you're good to go, right? And then from there, the Docker image that we have created, we can copy the correct files into the FAT partition and the right files into the root file system, and we would be ready to go, right? So those steps we'll see in a second, and I'll provide you the scripts and all the stuff in my Learn Linux GitHub repository. So no need to write it down or anything. You can see those files, those script files, etc., in the repository. So once you have created the partitions, then I have a script that will copy over the right files into the FAT partition and the right files into the root file system, the ext3, and so on. And it'll set up grub so that the disk USB disk is bootable, etc. All the good stuff. So that is the process of installation. One more thing is that when you're installing, you have to configure the grub using a grub config file so that the USB is bootable, right? It has to point to where the kernel is, what the partitions are, and so on and so forth. So there are two things to keep in mind. Some of this is constant, like root. The very first partition is what's going to be the root, right, for the whole thing where the kernel lives. And so this root is different from this root. This root is basically the primary partition, which is HD0 MS-DOS1. Inside grub, you will see that this would be the primary partition, the FAT32 partition for your USB stick. So this is what we write root here as, and that is where it'll find this Linux and the initrd image, right? This is where these two are found. And so they're stored in that location. Now, keep in mind that these numbers change quite a lot. If you run the Docker file again, it might pull in a slightly newer version of the kernel and generate its equivalent initrd. So this changes must be updated in the grub.config file. You must keep that in mind, otherwise you're not going to boot Linux. These two have to be right. Now, keep in mind, if you follow these instructions, it's going to boot. It's going to be fine because it'll find this kernel, it'll find this initRD image. They are all there inside the Docker container once we are done with the build because we have added all this stuff. The second thing to keep in mind is this root. And this root is not the same as this root. This root is the root file system location, which is the second partition. Now remember, we showed you that there are two partitions to the disk. This is the first, the primary partition where the kernel and the initRD are located. The second partition is where the root file system is located. And the root file system is basically this partition. And I'll show you when we get to the machine, I'll show you how to find this using the right commands. And once you know this, update this so that the grub is pointing to the right root file system. Otherwise, it's not going to boot. It's going to have kernel panic. When the kernel starts and loads initRD and gets to the root files, it's going to panic because it's not going to find the right partition where it can go and find the init, which is the very first program to run. So it's going to get stuck. So keep in mind here, this will probably not change for you. This will change for sure. And these basically every time you run it, sometimes these numbers change as well. So you have to be watchful for grub.config. It's very, very important that you get the grub.config file right, otherwise it's not going to boot. So try it out and see if you have this working. So and then I will talk about these challenges towards the end. But at this point, I think I'm ready to dive into the machine and show you that what files we have. So first off, I'll start with the Docker file because Dockerfile is what we will start with. It's just built from Ubuntu 21.04. You could do it from any Ubuntu, or you could even try other Linuxes, but you may run into some problems here because these commands are written for Ubuntu. apt get is a package manager in Ubuntu, and therefore these commands will not be the same. You may have to find equivalent commands if you're using like Alpine or some other really small, tiny OS or something. Now, inside this, I just do an update and then install this Linux image virtual. And then I also install Linux image extra virtual. These give me all the drivers in the kernel that I need. And then I install the uh, I guess the first program or the sysinit, which is also important. So systemd or sys5 are important. And then I install a bunch of other tools like Ethernet tools and so on, net tools. I also install some utilities for IP like ping, etc. And Python 3 is installed in there. I installed Docker, OpenSSH server wireless tools, and some other things. I'm interested in web servers, so I've also installed some of the web-based things so I can actually run web servers on this, like a Flask, Python Flask server or something. You don't have to. So you can take some of these off based on, but they don't take that much space. I think the big things are this kernel, and the kernel modules are pretty big. So you may have to see what you can do to cut down the size of this. One other thing is that this hskp.shell I copy, and this is I call it the housekeeping, but there are some problems and challenges. And one of the challenges is that when I install this, the root file system becomes read-only, and I have to run this command every time: mount-o remount, rw slash. This command fixes the fact that my root file system is read-only, and so I've put that into a shell script so that I can run that every time I come up. I don't have to remember the command. I can just go into my root folder and just run this. And then I try to create these Ethernet interfaces, but it doesn't always work. Remember that every time you boot in, you have to see what Ethernet 0 is mapped as, and you have to adapt your etc network interfaces file to your network so that it can boot. Sorry, it can run and connect. So that's very important. Then the second thing is you may have to update your etc resolve.conf for your DNS server. DNS server may not be correct. And finally, I've put I've put a user, Esponde. You could make a user that you want for your machine, and root is always there. So root and root password, so you can adjust your passwords here. So that's the Docker file, right? And clearly the Docker file as the concept was, we have added kernel and kernel modules. We have added systemd, which is going to act as our um, very first program, and also the manager for various services and so on. And so with that, let's look at how does this actually compile. So I'm going to open up the compile program. So the compile is very straightforward here. There's nothing very complicated. All you do is build the Docker and tag it with this. And then once this Docker image is built, all we have to do is export this as run it and export the container as the complete file system. Now, this file system is built in such a way that it contains both the root file system and the kernel um, and the initramfs. We just have to extract them and put them in the right place, and we'd be good to go, right? So this is only the build part, the compile part. So if you run this compile script, um, it'll basically build this uh, ubuntu.tar file, and that's nothing but just a Docker image that has been converted to a tar file. And the next step from there is what is more interesting, and it has all those parts. So if I look at this sp copy to part, this is my script where I basically use those two partitions. Remember the FAT32 partition that we talked about, and the next ext3 partition. Those will come in here handy. And oops, let me open up again. So a couple of things in this file to note: when you plug in your USB disk, be very cautious on what is your drive letter. In my case, it becomes SDB. So you have to be very careful. A USB disk here has to map here. The script will only work if you're good on this, right? It may corrupt some disk, maybe even corrupt your primary disk or something. You shouldn't just run this script until you know that this drive letter is B, right? In my case, when I plug in, I know the drive letter is B, and then I have these variables that say what am I upgrading. Now, in this case, the default should be 1 for all of these, um, so that what it means is that excuse me, I'm going to install the file system. I'm going to install grub. I'm going to install kernel. I'm going to install the grub.config file, and that is it. I want to install everything in my system. This is a brand new system. I want to install everything. But if later on, if you just want to upgrade grub config file, then you can just turn all these zeros and run the script again, and it'll only update the grub.config file without touching the other files. And that's the beauty of this script, is that it'll let you update pieces and parts of the USB stick. So that's one aspect of it. Now, if I go down, I'll show you what is actually happening in each step. If you look at installing grub, grub is installed in a specific part on the first, like the FAT32 partition. So that's the first partition. File system is installed on the second, and all we are doing is that we are untarring the ubuntu.tar, which came out of our Docker image or container, and we are just exporting that to the second partition. Then when we are done with that, we are just copying the Linux kernel, VM Linux, and the initrd image from that second partition. Remember that when we exported Docker container, it had a boot partition. It was not really a partition, it was just a folder, right? So the boot folder contained, when the Docker built its Linux image and so on, it added VM Linux inside the boot. So we're just copying that from the boot and storing it in the partition 1. So from partition 2, we copy the right files and put them in the first partition. And then finally, the grub.config file that I've showed you, I have already made the correct modifications so that my part UID is correct, and I can copy that. So that's what this will do. But now I'll show you this grub.config file. And the grub.config file, I showed you that there are two important things. One, this number has to be right. This number has to be right. So you must check that in your boot partition, what are these values? If you go to your first partition, the FAT32 partition, and inside boot, if you look for these two values on your USB stick, they have to match these two. Otherwise, it's not going to boot. So you have to get that right. The second thing is this root file systems part UID. Now I'm going to show you that in a second. So if you run the command block ID, you can see that SDB2 is sitting at part UID of this, right? And don't confuse it with SDB1 because SDB1 is where your FAT32 partition is. That's your boot part. We don't want that to be there. The root file system is the second partition. And so this 73cc-02, if you go back to grub, you can see that it's 73cc-02. This is the second partition, which is your ext3 partition. Remember, this root is where your first partition is. It usually, I mean, to me, it never changes. This is always HD0 MS-DOS1 because my USB stick is always seen somehow as like primary HD0. Um, and so this never changes. This is almost like invariant. Um, this this changes quite a lot, right? The initrd, whenever I run my Docker, it seems like, and if I run the whole all the build of the Docker, this number changes. So I have to update this. And then if I partition my, whenever I partition my USB stick, this number can also change. If you don't partition and you keep reusing those partitions, you don't have to change this either. So that's a quick summary of this. Now, uh, I'm not going to run this, but at this point I've showed you all the steps. So if you give it a try, when you open this copy to part, um, what you have to make sure is that this drive letter is correct, and then you have to set whatever you want to install. In the beginning, you want to have all these as one: file system, grub, kernel, and config. These four lines have to be a one, and then it'll install all these, and then your USB stick is good to go. Okay. So um, in this case, I have then copied my ubuntu.tar and provisioned it correctly on my USB stick, and I'm ready to go. Now there's still a couple of gotchas. Um, I'm going to now take this USB stick out from this machine and stick it into my other laptop, and I'll let it boot. And then once it boots, I'll log into that and show you that this is basically the OS that has been transferred into my Linux USB stick. So I'm going to pause the video here while I transfer and restart my laptop with this stick. I'll be back momentarily. All right, guys, so I'm back and I have now plugged in the USB stick, and this USB stick is basically booted the laptop, and I am going to SSH, um, and I have enabled root SSH, which is not something that is advisable, but this is just a beginner's thing, so I'm going to try that. Um, and then maybe we can try to SSH with the other user that we created, because we also created a second user. So I can see my IP address is 188. So yes, I would like to connect, and R002 is our password. So we are logged in, and we are now logged into our own Ubuntu. We built this from scratch using Docker, and we are now logged into this Ubuntu. Um, so the next thing is I'm going to show you a couple of things that I had to change on the network to make this work. So if you look at etc network interfaces, um, what I have set is EN01 iFace EN01 INET DHCP. So I've basically set the Ethernet wired interface to DHCP, and it's also possible to run wireless. But see there, if you see my root file system is not writable, and that's one of the challenges I'd mentioned. So I have put this hskp.shell file by default, and if I run this hskp.shell, now I can edit my interface file. Now my interface is called EN01, but yours may be called something else. So I would say if you run dmessage and grep for eth0, um, then you can see that eth0 was renamed to EN01. And so what you have to do is change this network interfaces file, and then you have to restart. So service restart, uh, service networking. Uh, restart, and that should restart your Ethernet interface. And in this case, it's going to also throw me off because I am logged in remotely. So it's probably, I'm not sure what's going to happen here, but I'm assuming it's going to come back. So I'm going to pause the video here and I'm going to make sure I can get back in because I basically restarted the networking while I was logged in remotely. So I have to make sure I can log back in. Okay, so we are back again, and what had happened was that as I restarted the networking, my IP address somehow changed. So I could not get back in, but now I am back into the machine, and um, I can continue to show you that etc networking network interfaces. And so EN01, DHCP, it's all good. And I showed you the dmessage command to run to grep for eth0, and that will tell you which. And the other thing is, if you look at this file, etc um, resolve conf, this would, if you're not getting your DNS to work, you have to add a name server and like 8.8.8.8. If you're not getting this, but when your networking starts, then something is wrong and you need to add a name server. In my case, I'm getting this automatically populated by my networking interface itself. And so if I do if config, you can see that I have my EN01 completely configured and it is working. It is linked up. I can ping google.com, no problem. And I'm connected to the internet, and I'm also connected locally. DNS is working and SSH is working. So things are good. Now, keep in mind that we did have to run this hskp.shell file because our file system was mounted in a read-only mode. And so you can even install this housekeeping function to be like automatic so that starts as a service when the Linux boots. Right now, I mean, I have put this in the root folder so that I can just run it. I don't have to memorize the command. But if I show you, it is just a simple command here, which is mount -o remount comma rw slash. So that was the only other thing. Now I wanted to also show you that I have this other user, right? So I should be able to log into my user. So um, I am going to exit out of my SSH session, and I'm going to try to log in into my other user because logging root is probably not a good idea. So, and there you go. We have logged in as the other user that we had configured in the Docker file, and the password and everything worked. And now if I do like uh, super user, um, and then, okay, so that's another thing. I guess we have to add ourselves to the sudoers group. Otherwise, I'm not going to be able to just sudo into the root. So that may be another thing to add on your OS to make sure that this user that I created had the root access. In this case, it does not. So the other way to go into this is, I believe, you can do su root and then root password, and now you're root, right? So that's another way, is if you want to execute commands, just simply su root. If you try to do um, um, let's just try, if you want to install something, let's say Vim. I'm not sure if it's going to allow, I'm sorry. Yeah. So uh, the user does not have root privileges because it was not added to the sudo group. So you can add the user to the sudo group, but for now, you can use the su root method, and from there, if you want to do like apt install vim, and it should work. So yeah, so it already did the work. Um, just as a let's install it, say htop, and you can see that, oh, htop is also installed. Okay. So I just wanted to show you something that I'm installing. Let's just say we install Emacs. Maybe it'll fetch something. I don't know. There you go. So as a root, I'm able to download and install packages, and so I'll let it install this. And I'm going to quickly pause this video just in case it takes time. Okay, guys. So that Emacs is installed, and we are good to go here. So also I wanted to show you that the size and the footprint of this file system is about 2.6 gigs utilized in a disk that's fairly big here. But I'm telling you that Ubuntu was, the last image, the last OS that we built was using Buildroot, which is only 10 megabytes. But Buildroot is quite a bit harder to add packages, whereas because this is Ubuntu, you can use the package manager. It's very, very flexible because it's the latest, greatest Ubuntu that we built. We can add any image, any feature of Ubuntu just by installing apt-based mechanism. So you can add anything, you can add any packages that you want at your will. It's only 5% of the disk is utilized here. So one final thing is that I wanted to show you how to use dive. So when you have built your Docker image, you can run this command dive and use your tag. In my case, my tag was my Linux Ubuntu. And if I run this command, the Docker image is going to pull up inside this dive tool and show me what each step added, like what was the cost of each step in terms of megabytes that just by adding more and more packages to my image, how did I get my image so big? I'm at 2.6 gigs, which is not small. And although it may be small compared to like when you try to install it from like a downloaded ISO, this is still smaller, but it's fairly big when you compare it to Buildroot. So Dive is the tool of choice that'll show you that where the cost came from. So it's almost there. It's building up the cache, and then there you go. So here inside Dive, you can see that this first it started with the Ubuntu, which is fairly small. But when we did this Linux image installation, it gave us 114 megabytes. And when we did extra virtual, this brought in a whole bunch of things. On the right side, you can see what all came in, right? So it gave us a whole bunch of things. And if you want to, I think you can use tab to switch view. So you can go down this and see where the huge costs came. And probably it's the modules. It's usually the modules, Linux drivers and modules that are fairly heavy, and and they are very expensive. So I think in this case, and I'm not going to spend too much time here, but you can go by hitting tab, you can switch between these two windows. So clearly you can see that the big cost came from Linux Image Extra Virtual here, and then the system D, which is our um, system manager, and also the very first program that gets called. That gave us 544 megabytes. And then all these other layers were okay, but this was big. OpenSSH, Docker. I bet Docker is a pretty big and heavy installation. So you can choose to remove some of these packages. Just remember that you have to have the Linux image virtual uh, and Linux image extra virtual and systemd and system 5. Those are critical, right? This is critical, this is critical, and then systemd, system 5. These are critical tools. Without this, the image is not complete. It's not going to work. Um, in fact, extra virtual, it may work. I think Linux image virtual is absolutely must, and systemd, system 5 is a must. These two components are a must before you try to push it to a USB. So that's the important stuff. And then keep in mind that when you come up, you may have to set up your network card, your Ethernet port, um, and if you get your Ethernet port going later on, you can also enable wireless. I have successfully enabled wireless by using the network tools, and I can do another video just to show everybody how I got my wireless working, but we will not do that in this. For this video, we'll leave it for the wired Ethernet, and that's about it for this one. So going back to our challenges, just as a reminder, there were some failures during the boot. The Linux kernel was spitting out a couple of errors, which I have ignored, and it seemed like they were not really bad errors. So some failures that may need some more debugging and future, you know, changes to make them smooth and all green through the boot process. So that's still work in progress. Copying files to USB, I would say use USB 3.0, which is maybe five to um, 5 or 6 times faster. It it's way faster than USB 2.0. So if you're copying files, that's gonna save you a ton of time. Go buy a USB 3. It's only like $20 at Amazon, so you should be able to do that and get quite a lot of speed. When you're copying, there is a sync command in my script folder, and in my script when I do the copy to part, that script has a sync command. If you were to pull a USB out while it's syncing, the file's not going to get copied because a lot of files in Linux caches are not flushed if the sync command is not executed. So it's very, very important that your files are pristine, the copy is perfect. Otherwise, it's not going to work. It's nothing wrong with the way you built it. It's just you have not, uh, copied all the files correctly because the copy was in process. Some of the files may be in the cache, Linux's file cache, and so on. So you have to make sure that the sync is flushed and you have a perfect USB disk or a hard disk for that matter. The root file system was read only. I already showed you the command was mount dash o remount comma rw slash. I still have yet to figure out why that happens, but it happens. And then when you run that command, it puts you back into the rewrite mode, and you are good to go. So that's it for this episode, guys. If you followed all these steps, hopefully you have a working copy of Linux straight from Docker. That's an amazing achievement. You have gone from Docker, which was supposed to be, not a full-blown Linux, and you have added pieces and parts that made it a full-blown Linux. You have installed it to a USB and you have plugged the USB into your laptop or whatever, um, and then it has worked and it has given you a full-blown Linux, which you're totally in control of. So the the remaining piece here is that I have not cross-compiled. So I've only compiled the Docker Linux on an x86-64 machine. I have taken that USB, plugged into another x86-64 laptop. And so, in my opinion, it's working for the same architecture. If you compile it x86-64, you can plug that into another x86-64, but do not do that by taking something that's compiled on x86-64 and plugging into something completely different architecture, like plug into an ARM or Raspberry Pi or something. It's not going to work. Um, so that's still a challenge as to how we build from Docker and compile it and then plug it into another system. It's not cross compiling. So we have to figure out how do we cross compile in a future video. So that's about it for this episode, guys. And thanks so much for watching. If you have already not subscribed yet to my channel, you can see that I'm bringing quite a lot of quality content, and it takes me quite a lot of time investment to bring these. So if you can subscribe to my channel, at least you're telling me that this is something that you are interested in, and that will give me some motivation to keep making these in the future. And so with that, I end this video, and I'll see you in another video some other time. Thanks a lot for watching and stopping by, and bye bye.